Broadcasting live from the Business RadioX studios in Phoenix, Arizona, it's time for Phoenix Business Radio, spotlighting the city's best businesses and the people who lead them.
Welcome to Phoenix Business RadioX. I'm your host, Karen Nowicki, and I'd like to welcome you to AZ TechCast, sponsored by Arizona Technology Council. AZ TechCast is dedicated to covering innovation and technology in Arizona and beyond. Broadcasted monthly, AZ TechCast invites leading experts to have real conversation about what's happening in the tech sector across the state of Arizona. From regional news to innovative startups, companies, and emerging technologies, AZ TechCast covers the critical issues and economic trends propelling the state's growing tech ecosystem. I'd also like to thank Arizona Commerce Authority, AZ TechCast 2020 Innovation sponsor. The Arizona Commerce Authority is the state's leading economic development organization with a streamlined mission to grow and strengthen Arizona's economy. The Commerce Authority uses a three-pronged approach to advance the overall economy: recruit, grow, and create. Recruiting out-of-state companies to expand their operations in Arizona, working with existing companies to grow their business in Arizona and beyond, and partnering with entrepreneurs and companies to create new jobs and businesses in targeted industries. In addition to Arizona Commerce Authority and Arizona Tech Council, I'd also like to thank our 2020 Tech Advocate sponsor, JDH Insights. A leader in coaching and executive development, JDH Insights is committed to helping organizations cultivate and leverage their most important and complex asset, their humans. JDH Insights uses a holistic approach to align people with the organization's mission, vision, culture, and performance objectives to create engagement and achieve results. Please visit jdhinsights.com to enhance leadership and improve team dynamics to take your business to the next level. And with that, let's give a warm welcome to today's distinguished panel. We have Benjamin Hernandez, co-founder of Arizona Spaceport Alliance and co-lead of Kaiser Aerospace Practice Group, Dr. Jeffrey Hall, director of Lowell Observatory, Dr. Matteo Genna, Chief Technology Officer at Worldview Enterprises, and Steve Zylstra, President and CEO of the Arizona Technology Council. With preeminent observatories, leading aerospace companies, and innovative technological advancements in space and science research, it's easy to see why Arizona is an emerging leader in the world's never-ending quest to discover the secrets of our solar system and universe. During today's TechCast, these distinguished experts will discuss how Arizona's ever-growing innovation in space research and technology is changing the world we live in and enabling scientists, physicists, and astronomers to better understand the mysteries of our galaxy. We have a lot of ground to cover, so let's get started. And Steve and I both always laugh after each of these episodes how quickly the hour goes. Right, Steve?
Absolutely.
Well, today is an exciting conversation.
Thank you, Karen.
Yeah.
Great to have such a distinguished group of aerospace and space leaders today.
Right here in Arizona. I would love for each of you to briefly introduce yourself before we get into the topics for our conversation today so that our listening audience can get to know you and a little bit about your background. Who would be willing to start for us?
I'll begin.
Thank you, Benjamin.
Good afternoon, everyone. My name is Benjamin Hernandez. I'm a co-founder of the Arizona Spaceport Alliance, a nonprofit effort here in Arizona to try to identify a site for a spaceport that is apply for a launch site operator's license. Whether it's vertical or horizontal is kind of irrelevant to us, and we are site agnostic. We're just really interested in advancing the aerospace market in Arizona through the advancement of space. And we're doing that for about 3 years now, going on 4 years, and it's been a very exciting process. You learn a lot of new words along the way, and you meet a lot of really exciting people with really exciting conversations, and I think this will be an example of that.
For sure. Yes, thank you so much, Benjamin, for kicking us off. Who'd like to share next?
I'll go.
Thank you.
I'm Jeff Hall. I'm the director of Lowell Observatory in Flagstaff. I came to Lowell in 1992 as a postdoc on a National Science Foundation research grant on a 3-year appointment. And we were joking before the podcast started that I've not, in fact, been here for 125 years, but been here pretty much my entire career. I've been the director since 2010.
Wonderful. Welcome, Jeff. Thank you. Matteo.
Hey, good afternoon, everybody. So my name is Matteo Genna. I've been in the space business for a little bit more than 25 years. Most of it has been on satellites and spacecraft. Moved to Tucson, Arizona to join Worldview Enterprises. And Worldview is a company that does stratospheric balloons. So we actually work in near space. So a lot of the technologies and the elements are very similar to what is done in space. One major difference are balloons that we use these balloons to get us into the stratosphere. But ultimately, much of the same technology and disciplines that are used in space.
Fantastic. And I would not be in good spirits if I didn't ask Steve to introduce himself and to thank you for giving us this opportunity to bring this series and these important conversations to Business RadioX and, of course, all of our listeners. Stephen, tell us a little bit about you and AZ Tech Council.
Thank you, Karen. I very much appreciate it. I'm president and CEO of both the Arizona Technology Council and its foundation, which is called the SciTech Institute, where we focus on STEM, science, technology, engineering, and math. Run a bunch of programs, including the SciTech Festival and the Chief Science Officer program. I should also say I'm an engineer. In the early 80s, I worked on the control moment gyro for the Defense Support Platform, which is a spy in the sky. And so I've had a little bit of aerospace and defense experience as well. I was in that industry for about 20 years before I started running tech councils.
Wonderful. And the SciTech Institute is, their team is right here at MAC 6 where the studio is, which is so wonderful. And in addition to having the wonderful opportunity to host the AT Tech Cast, I also have STEM Unplugged, where Kelly Green comes in with one of their CSO, a high school student, to have conversations with all the people who are in different STEM industries. And we always have great conversations. So I feel very blessed to be a front row seat for that conversation as well. Let's kick off today's topics with just jumping in a conversation. And for our listeners who've been with us before, I like to pose the questions and then I like to see where it takes us and ask each of you to just kind of jump in and riff off of each other as we go. Just how much does aerospace industry contribute to Arizona's economy? And why is Arizona so ideal for this innovative industry?
Well, I can speak to the astronomy side of it. As noted, Lowell's been around for 125 years. We were founded in 1894. There's two basic things about ground-based observatories. The most powerful optical telescope in the world can't see through clouds. And the less atmosphere there is between your telescope and the objects you're studying, the better off you are. So observatories like to be in places with clear skies and high elevation. And in the continental U.S., Arizona is pretty much the ideal spot for that, both with obviously the high terrain up here in the northern part of the state, the Sky Islands to the south, and a high fraction of clear skies, considerably better than in Boston, where Percival Lowell was from.
Yeah, that about sums it up. I mean, when you talk about ideal space conditions, and if we're going to advance technologies in space, there is no place like the United States, and there is no place like Arizona in the United States, simply because of what Jeff just said. We have access to the skies more often than anyone else.
Go ahead, Matteo.
I would add to that for any industry, whether it be space or otherwise, it's really about the talent to build the teams up. And within Arizona and the universities within Arizona, that we clearly have a lot of that available to us. A lot of people actually end up living where they went to school. That's a pretty common experience. So it's really important that we have these world-class schools within Arizona. But I would also agree that the space within, for Worldview in particular, having the space to be able to launch and operate within Arizona skies is makes it a lot easier, and it's hard to beat the cost of living. So.
Karen, also, virtually every prime contractor that's in the aerospace and defense industry operates here in Arizona. You've got Lockheed Martin, Boeing, Raytheon, Honeywell, BAE, Northrop Grumman, and others. And as a consequence, we have a significant workforce. in this area. And you combine that with the academic programs that we have at 3 universities, and it's hard to beat.
I was going to ask that next, and you and Mateo both spoke to that. How do Arizona's world-class programs at the university level contribute to accelerating its success in aerospace, defense, and astronomy? Can we talk a little bit more specifically about how that's getting done?
Through real-world projects and private industry, I think more than anything else. It's funny. About a year ago, I had to do a presentation introducing the Space Force to a group of individuals here in Phoenix. And in the process of research, I ended up going back to the basics, which was Air Force and NASA. And as I started to look at just how many developments have come out of the Air Force and NASA, I started to extrapolate what possible technologies could come out of a Space Force. And at the end of the day, it takes money to do a lot of these things, and it's hard to beat the amount of money that the government can throw at something. But when you start talking about universities and real world applications, especially with something as advanced as first lens technology at U of A, but just Mars missions at ASU. And let's not forget Embry-Riddle, who has, I think, the only space degree with their spaceflight operations. And it's hard to beat Arizona for the advancements of any of sort of technologies that's going to be needed for the future. It really is tough to beat. Not to mention we have, it's kind of a sore issue, but we have California next door, which has the highest concentration of rocket engineers that can't afford to live in California. And so you end up with this really nice pool of experienced individuals that are getting these jobs done and creating these new technologies.
Yep. Thank you, California. Jeff?
Yeah, thanks for mentioning Embry-Riddle, because I was going to point out too, all 3 of the state universities have major programs in astronomy and planetary science, U of A, ASU, and up here at NAU as well. And, obviously this has been a bootstrapping thing since this is such an ideal place for astronomy. It's natural that it would attract quality programs, but this brings the critical mass of intellectual horsepower in terms of world-class faculty in astronomy, and then all the related disciplines of, engineering and optics. And that then in turn attracts the very best and brightest students to the state to study and live here, and that's a good thing.
Yeah, I would agree. And also, even in from the more conventional aerospace type of activities to ASU leading the program to go to asteroids and be able to study the Psyche asteroid, which is being worked on right now for a NASA program. So it really runs the gamut from the within aerospace, the more mundane standard, which is not really nothing's really quite mundane standard within aerospace, but from the more common to the real end of exploring our solar system.
A lot of folks don't know that U of A, when we think about space programs, we think of Houston or Cape Canaveral, but the Phoenix project was actually run out of U of A, and so is the OSIRIS-REx program, which is going to scoop up some material on an asteroid and bring it back to Earth. I believe is it on its way back yet?
Yeah.
I think it's on its way back. But nonetheless, an extraordinary program, all managed out of the University of Arizona.
Provide some insight for our listeners, if you will, on some of the higher education and industry partnerships that promote entrepreneurship and innovation while facilitating cutting-edge space technology commercialization.
Okay, well, from the astronomical standpoint, for example, we are an independent nonprofit institution, so we're not formally affiliated with any of the universities, but we do have a formal agreement with NAU for access to our 4-meter telescope. And so that stimulates interaction between us and their faculty. We have formed additional partnerships with Boston University, University of Maryland, University of Toledo, and Yale. And so those are, their faculty and their students, well, when we can travel, of course, that brings them and their projects and intellectual horsepower to Arizona. And of course, these kinds of collaborations exist at other institutions as well. So this sort of rich network of collaboration forms that has, cascading benefits.
And outside of outside of the U.S. as well. Right,
oh, for sure.
Yeah.
So Jeff, what role does private industry play in those relationships? That's really interesting.
Yeah. So, for instance, for the construction of our 4-meter telescope, that was a $53 million project, we contracted that within state to the greatest extent we can. So, for the steel and the construction of the dome, the primary mirror for the telescope, so it's this 14-foot mirror that's about that thick, was cast at Corning in New York, but the 3-year contract for final polishing went to the College of Optical Sciences down at U of A, not the lab under the stadium, but up the street. And they did a spectacular job with it. This is major infrastructure. And, we try to tap Arizona industry to make it happen.
And Stewart Observatory is within the University of Arizona, run by the University of Arizona. And the Mirror Lab that Jeff just mentioned is actually in the basement, if you will, of the stadium, and constructs and polishes some of the largest mirrors in the world. I think they did the one for the Chile Observatory. Is that correct?
They can do up to 8-meter mirrors, and they are in the process of doing them for the major facilities both here and abroad.
Yeah, they make the world's best mirrors and lenses. There's no doubt about it. I don't know how they struck such a gold mine so early on. It's been a real treasure to have them in Arizona.
Yep. Our primary mirror with the Lowell Discovery Telescope, it exceeded spec for its clear aperture as well as the structure function at all scales across the surface. They got it way down there, and the image quality is just to die for.
Yeah, also, the U of A just excels at the optical technologies, and it actually has spun off many companies within Tucson. And there's other companies like Freefall who has ties back to U of A, where they were able to develop some technologies and then work towards commercializing it.
And Karen, we have 75 members, mostly in Tucson, that are in the optics and photonics space. The largest concentration of those kinds of companies in the world is in the southern Arizona area.
Yeah, I know last segment you talked about, and I hadn't realized it, how frequently you are between the Metro Phoenix area and Tucson, again, just to continue to bring everybody into these kinds of conversations as it relates to Arizona's technology industries and bringing more of these companies and these great institutes into our state.
A lot of these conversations that I come across with companies, they almost all revolve around workforce and workforce development and future employees. And the idea that, you have these different satellite locations like Polytech just outside of Phoenix Mesa Gateway, that's an ASU location, is really intriguing in that we are able to compete with the most advanced technological universities in the most advanced fields. It's becoming to the point, it's almost comical, where I meet a kid from ASU and he considers himself a rocket engineer. But when you start talking to him, he really is a rocket engineer. And, we're in the middle of a competition at ASU to develop a rocket to reach the Kármán line through liquid fuel propulsion and engine development, which is new. And it's the Helios project. And immediately we started reaching out to private industry, and the ASU alumni stepped right up and started donating money, sponsoring it, donating material and expertise. And they were stunned with how cohesive the Arizona industry in that way is, and how uncohesive it is when it comes to doing business with each other. And so U of A has developed a space roundtable. And it's a very successful monthly event. It's free. And Stephen Fleming runs it. And its only purpose is to strengthen the development of space commerce in Arizona, as opposed to space science. Elements like this that exist in Arizona that are unique to Arizona and that include often very much companies from California, Colorado, and Nevada, and sometimes Texas. These are examples of how the private industry is really starting to get hungry and look for what they can accomplish where, and Arizona is often the answer to that question. And workforce development is where we're really advancing.
By the way, Stephen Fleming is a board member for the Arizona Technology Council. And many of our member companies participate in this roundtable.
And the conversation has to be, right, ongoing. We can't go do something in a silo and not reach across the aisle and offer support. And I think Jeff expressed it so well, how when you involve so many different people and enterprises and educational institutes, how much quicker and how much better we can succeed and stay in the top of our fields. Yeah.
There was a question earlier about the collaboration between academia and industry. The folks may not realize that every major school or institute or center has an advisory board of people from industry. I've actually served on the advisory board for the College of Engineering at U of A for 30 years. So every major program has these kinds of advisory groups. All those prime contractors I mentioned earlier, all of them serve on that advisory board for the Dean of Engineering at U of A. And companies like Caterpillar and Paragon Space Development Corporation, Grant Anderson, I'm sure you know, Matteo. So there's a natural interaction going on a regular basis because of those advisory boards.
What would each of you say to a student, whether they're in going for their bachelor's or their master's, or even their doctoral work, around how to show up on the business side of things? Is that important as they are landing themselves in the field and trying to make a name for themselves? What would be your recommendations for someone who wants to put themselves out there and get to know the people who are really doing the work?
What I would say is that one of the more rare skill sets that you see is the people who can live in that intersection between the business and the technology. It's hard to work on the technology not knowing what the purpose of it is, or why do you want to do it? What's the use for it? And equally on the business side, it's hard to make good business decisions if you don't understand ultimately what ends up being limitations, right? You like to do things and we're limited by technology or materials or the like. So what I find is that people who can live in that intersection really excel. They can really do quite a bit, and having a real good business sense, always thinking about, whoever your customer is. I mean, that's a very broad statement. A customer, that can mean almost anything to different organizations. But what does the customer really want, as opposed to what can I do? I think that's a really important skill if you could develop that.
I think, except for universities, academic institutions, we all work in a business environment, right? And so it's important for all of us to have an understanding of business. And for those students who also have an entrepreneurial bent, they may be very savvy on the technical side and have an idea for a business in that area. It's critical that they have an understanding of have business acumen.
Yeah, I'm going to disagree a little bit with that, because what happens is we end up needing a translator between the technician, who's often an introvert, and the business side, which it requires networking. And I'm not so sure how much I'd like the technician to start focusing on the business, the artist, so to speak, because we need him to focus on the technology. But to Matteo's point, the individual who can carry both hats, wear both hats, does remarkably well. Networking has always been important to business, and if you can use your student card to get in front of a CEO, just to put your face in front of them, start asking intelligent questions, that's only going to benefit you when you graduate. And outside of that, quite frankly, Jim Cantrell gave a presentation for the Space Roundtable, in which an engineering student asked him what type of of engineer he was looking for, and how could he apply for a job at Vector. And Jim answered very frankly, what I really need is individuals who can get out of the theoretical. I love that you're getting the education, and I love that you're learning the knowledge, but when I give you a problem, I need you to be able to solve it without me giving you everything that you had in school. And so the practical application and the practical knowledge, and even if it's just volunteering somewhere where you're handling, next generation antennas at freefall, all of that is really beneficial. And it's hard to let go of the basics when everything can be learned on YouTube.
Yep, I agree with that last part. And I will always advise students, undergrads, to be sure to try to accumulate some research experiences. And there are specific NSF programs to enable that. We operate an RU program, NAU has one. And to get that real world experience, whether it is with maybe a pure research project, or for instance, we have a number of NAU students who are working as engineering interns out at the Navy Interferometer near Flagstaff, and they're good. And I want to come back a bit to what universities bring to the state, and compliment these students, because whether on the research projects or engineering, the ones we have at Lowell are really bright, and they get stuff done, and they're getting this practical experience. We also employ quite a few NAU students in our outreach programs, and so they are getting public speaking skills, crowd management, delivery of information at multiple levels, and they're really good at it. They're these energetic, enthusiastic geeks that just give everybody a great time, and they're a real asset to the community. So yeah, I try to encourage the introverted scientist types, which I can certainly relate to get those broader skills that will allow them to function with the engineer working off the Gantt chart, and the astronomer working off a research project that you don't know when it's going to yield a result.
Yeah, I want to second that. Communication is one of those things that you just cannot undersell. You're communicating clearly, understanding whether the audience even heard what you just said. It's that element that is you don't often get coming out of school, right? I mean, it's where you're able to take a test, but that communication skill is how everything works, within any industry. So,
and thanks for saying that. That's one other point I make, is particularly in the academic tracks. You're going to have to write proposals, and what's going to happen. The review panel is going to have a stack of proposals like this, and they're going to be able to fund 2. And if you can't wield the language effectively, you're at a real disadvantage, no matter what your science is.
Steve mentioned.
Yeah, those. I'm sorry, Karen.
Go ahead, Matteo. Or sorry,
I was going to say those support skills get lost in all these technological discussions. Project management. Just the ability to know what a Gantt chart is and how to follow it is not something that theoretically the guy working on the advanced, 0 degree, zero gravity plumbing should be thinking about. But that guy needs the project manager underneath him to keep everybody in line, because not everyone's going to know what the other side's doing at any given moment. And you can look at any one of these primes, Boeing, you introduce somebody to Boeing on one end of the field, but they really needed to be on the other end of the field. And there's 1,000 departments in between the two. So there's an understanding that mission accomplishment at the end is a support system for whatever has to be done. Yeah.
Yeah. Actually, if I can just say something, because the thing for me personally that has always excited me about the job and the work in aerospace is how many disciplines, how broad the type of things you have to think about and worry about, and the endless number of experts. I mean, experts from rockets to like bolts. People that are spending their lives understanding how every bolt works. So the one thing I would say that is really critical for any person going into aerospace is they have to be a lifelong learner. They have to constantly be willing to learn new things, ask questions, ask stupid questions, just keep on having that hunger to know more. If you have that, actually that goes a long ways. So,
Karen, I'd like to pose a question to Jeff. Jeff and I have worked together on what are called our dark skies for many, many years, and to protect our dark skies. If Jeff, we talked earlier how important our weather was, right, for the aerospace and defense industry. For the astronomers, our dark skies are what's critical. If you could speak, Jeff, to what are dark skies and why are they important to observatories and astronomers?
So how many hours do we have here on the that's obviously a big topic, but yes, it is critical. Modern astronomical telescopes, we are pushing the limits of detections at or below the natural sky brightness. I mean, of a completely dark sky. The slightest bit of sky glow and light pollution degrades your ability to do this and that kind of program. Arizona, as one of the astronomy capitals of the world, has always been very proactive. Flagstaff was the world's first international dark sky community, awarded by the Dark Sky Association, which is headquartered in Tucson. There are a number of dark sky communities around Arizona. I've really been trying to support. I mean, we were saying, Steve, in the ASTC policy guide, supporting the efforts of these communities. Gets dark sky status should be one of our priorities. One of Arizona's dark sky communities, kudos to them, is Fountain Hills. And that's, a sign of the very smart way that IDA set this up. To be a dark sky community, you don't have to have a dark sky. You just have to have a local commitment to good lighting practice. And, we always try to point out, dark skies doesn't mean dark ground. It means wise application of lighting that actually improves conditions on the ground without wasting it through uplighting. Now, we are at a watershed moment from the ground and from space in dark skies right now. Because all around the world, we're making this rapid switch from legacy gas discharge systems like high pressure sodium to LED. And the default LEDs that communities tend to install for outdoor lighting are whites of various temperature. And lumen for lumen, a white LED will generate twice the sky glow, at least 50% to twice more than HPS. And so this is a real chance for substantial expansion of sky glow worldwide, which not only has astronomical, but environmental and health implications. And then from space, as we've heard, there is the coming mega constellations of communication satellites, such as SpaceX and Amazon and OneWeb are working. I'm the chair of the AAS Light Pollution, Radio Interference, and Space Debris Committee, and we've been working very closely with SpaceX. And I can compliment them for taking a very proactive stance to try to darken their satellites as much as possible. And we're opening conversations, had a telecon with OneWeb yesterday, and just trying to get astronomy and industry together, despite a potentially conflicting situation, to work as collaboratively as we can to live together as we enter the era of the industrialization of space. So critical days these are for dark skies all around.
I'm curious from a just general lay person and community perspective, as well as the municipalities, what responsibilities do we have, and does the city government have as it relates to some of these issues and challenges you're faced with?
Well, I mean, the Phoenix City Council did a good thing. Instead of the very high temperature LEDs with input from the dark sky community, most of them are the 2700 degree, which are a warmer color. There's still going to be more sky glow than high pressure sodium, but they're much better than these blue-white high temperature LEDs that many communities seem to install as kind of a default, the 4,000 or 5,000 degrees. At the community level, you can advocate for responsible use of lighting, which means shield it so it's all going down, and use it when you need it. Don't leave floodlights burning all night. That's you don't need them when you're sound asleep.
And the Tech Council has served as sort of a convener of the astronomy community and, in this case, the billboard community. Billboards have a lot of uplighting typically. to help them appreciate and understand the impact that they have on our dark skies. And we had a really great meeting last December with all the major billboard enterprises in Arizona. And, that gets the dialogue going and get people to understand why it's important. And and as Jeff pointed out, part of our public policy initiative is to maintain Arizona's dark skies.
Mateo or Benjamin, anything you want to add to that particular topic?
The only thing I would add is that there's nothing more important than zoning ordinances when it comes to these types of decisions. Once you get the community on board, theoretically the community through the council, then you really have a real commitment to building and developing in this manner, whether it's traffic flows or lighting. It's a beaten horse, but voting matters. You get to know who's going to make the decisions for you, and you try to really instill what's important to you. And that's where organizations like the Lowell Observatory or the Tech Council, for that matter, are really important. They make the case for you without you having to show up to every city council meeting.
It wasn't until I had the opportunity to get to know Steve and the AZ Tech Council through this podcast that I realized how involved you are in policy and advocacy. It's a big role that you play, right, Steve?
It's one of the most important things that we do. We attempt to be sort of the voice and the face of the technology industry with legislators at both the state and federal level, and do exactly what Benjamin just said, right? Be that interface on behalf of an entire industry with the people that are making the decisions, and bring the experts in. Jeff has done testimony many times for us at the legislature. So, again, convening the critical people in order to make the case.
And staying in front of the decision makers.
That's right.
Yeah. Fantastic. What innovative space technologies can we expect to see in the near future?
There's too many to name.
Well, Jeff already set the pace for us being here all day, so go ahead and go for it.
What I'll say is that there's kind of this really broad trend that's probably been happening over the past 10 years, 20 years, where space was the realm of governments, right? Only governments were able to do things within space. And then, somewhere around the 80s, early 90s, what we saw was a whole much more large corporations, large companies were able to afford to do things. And certainly within the last generation, there's this more, it's being driven down even further to where, students can do things that go into space. So that very much started with this, it wasn't even, I guess you could call it technology, but it was just kind of these things called CubeSats, where basically just created a standard way to put things together that allowed students to then just actually put things in space and test out things. So there's more of a trend towards a broader participation in space. So like the kind of thing that we're doing at Worldview, as an example, is what we refer to as near space. So high altitude platforms. There's many companies out there right now working on different high altitude platforms. And the value of that is that it just has a different cost point than traditional space. And so there's a lot of things one can do, like Earth observation from the stratosphere that one can do from space. So it's not exactly a technology; it's kind of the summation of all the technologies. But there's a definite trend of more participation at different levels within space.
Yeah, when I said there's too many to name, I meant that quite literally. In that, in my opinion, everything that man has created and invented is going to have to be reinvented and recreated for the rigors of space. We're going to reach a point at which everything that we do on Earth is going to be done, let's just say, in cislunar space or in the moon or even in Mars. And so just the process of getting there by virtue develops new technologies. You got to deal with the actual application of that invention. but you also have to deal with the temperatures, the pressures, and the radiology in space, the radioactive activity. So you really have this idea where something as simple as an armrest for a vehicle, you really have to think through the technology, and that's called materials technology. Very important right now. No one talks about it, but it's very important. What materials are going to be the best choice for any particular application in space?
Yeah, they previously coming to Worldview, I led a group where we worked on robotics that were used in space. And the one thing I always told the team was, the one thing I know is that there'll be more robots than humans in space in the future. And that's part of, as Benjamin mentioned, that's part of the reinventing, how do you do things? I mean, space is not very human friendly, right? So what kind of tools do you bring? What kind of materials? How do you build things? And robotics right now is a major. It's been used quite a bit, as all Mars missions use robotics. These asteroid missions use robotics, but even to the point where people are developing robotic systems that will fix satellites, that will go up there and actually, if the satellite is broken or needs a replacement. So today you go bring your car to your mechanic. In the future, you'll send this robotic mechanic to fix satellites, and that's currently being worked on right now. That's not science fiction. It's being worked right now. So.
Yep, it is. And I would go back to the vision of providing broadband internet access to the world, in particular underserved areas, which is sort of SpaceX's vision, through a fleet of communication satellites. That's innovative. It's an innovation that collides with ground-based astronomy, and we're trying to work that issue. But nevertheless, one other that people are discussing in astronomy, if you need instruments or components in space too large to be fit in a fairing, say, print them. Send a printer up and print them, and then you can do all sorts of cool things that you might not necessarily be able to launch, and that's seriously being worked on too.
That's actually been done. There's been printing on the space station. Yep. They've done printing. So all this is all currently. It feels like science fiction in some ways. But when you start looking at all these companies, as Benjamin said, the number of things that are going on, it's a lot of the science fiction is happening right now.
Benjamin, you got me thinking when you were speaking about the possibility of humans living on Mars. Is that even doable? Yes, Mateo's nodding his head yes. So is Steve. Wow.
Yeah, I mean, the timeline is kind of debated and the actual mission, but there's little doubt in everyone's mind that it's doable at this point. It's just a matter of time.
Right.
Yeah. I mean, it's funny, the movie Mars, The Martian, one of the big problems was the communication and the lag time between that communication. But in reality, that's going to be one of the smallest hurdles, because we're going to have micro satellites along the way that are it's not going to be instant, but it's going to be much faster than dialing some robot, through code. I know we're really reaching the levels of Star Trek is the reality. We're 3D printing food, self-healing materials, self-healing concretes. There's no reason why that's not going to be applicable in the future to metals. And it's just it's amazing what we do when we start really putting our minds to a mission. And the other thing that's really different now is that while it was a venture of large countries and essentially just the United States and Russia, now it's a venture of a lot of smaller countries with the large countries. And despite the competition between the United States and Russia, we collaborated on a lot of that. I mean, the space station got built largely through collaboration. We've been getting our astronauts to space since 2011 through collaboration. There's really more in common than in opposition at this point. And we've reached the point where if we lose satellites, we run the risk of going back to, pre-technology days. We're so ingrained in what technology does for us. Most of us can't read a paper map. I don't know if it's most of us, but it's the kids for sure.
Right.
I mean, they have no idea.
What is a
Karen, I just want to add a little flavor with respect to one of our members. We all know that Elon Musk has a quest to get us to Mars. And he has lots of skeptics, but, he just put 2 people in space on the Falcon 9. He's done pretty well with Tesla and solar and so on. But the interim step is going to be going back to the moon and putting facilities on the moon that become a base, if you will, for getting to Mars. And one of our member companies just won a major contract for the next moon mission, and that's Paragon Space Development Corporation, which is also in Tucson. So, there's a plan. It's as indicated by Benjamin, there's differences of opinion of when, but I think we're going to get there.
But I'll also say, something Benjamin brought up is the communication. That is starting to be seen right now. That, in order to talk to vehicles and landers and stuff like that in deep space, there's a communication system that NASA has built in order to facilitate talking to those things. That's starting to get jammed. That is, they're working on the next generation communication system, because think like basic infrastructure, just how do you talk to these things, is starting to get jammed up. That's just a sign of how much is going on right now.
That leads me to ask, and I'm not really sure how to best articulate this, but whose job is it for space preservation as it relates to sustainable practices?
Is there a job?
I don't know, right?
That's one of the jobs that our kids are going to be doing that don't exist yet.
And that's why I'm asking that question, because, I grew up in the 70s, and for some reason, I was always wanting to take care of Earth and pick up trash and do my duty and that sort of thing. And when I later became a teacher in Kyrene School District, I was the first one to launch, the recycling program and those kinds of things. I only know what I know as it relates to Earth and my responsibility here. Are we having those same kinds of conversations as it relates to space and the sky? And if we're not, should we be?
So there are, and so that's often what's referred to as the commons problem. Like the oceans are common, and whose job is it to? At the end of the day, it's got to be some agreements across industries and governments to do this, right? Some, whether it be treaties or otherwise, to just put some sort of teeth behind it. But I do, I have seen that a lot of companies, like Starlink on SpaceX's, you can imagine that way in the past they would have said, I don't care. I'm going to do what I need to do. But they don't do that, right? They don't do that. And a lot of companies do care about these things and do think about them. And so I think there's a certainly within the U.S. and certainly within Europe, there's a kind of this cultural understanding that this is our responsibility. But ultimately, for it to work, it's going to have to be multinational agreements.
Yeah, and one of the things I would say is that every piece of garbage, if you will, that's in space is currently being tracked. Everything. And, the military doesn't want any of its satellites taken down. So it's keeping very close track of that. And there have been a lot of SBIR, Small Business Innovation Research topics that focus on taking care of space junk. There hasn't been anything launched to do that yet, but people are innovating around ideas to clean up space.
Jeff, did you have something you wanted to add as well?
We are also starting to have those conversations. As Matteo pointed out, I think that the current satellite operators are being very proactive and very responsive about trying to be responsible citizens. That said, you could also have the I don't care operator. There's really nothing to stop an operator from launching a fleet of 5,000 visible eye satellites if they had the vision and the resources and the business plan. So, we have just wrapped up the report from our Satellite Constellations Workshop 1, published by the AAS. You can find it online. That was strictly technical. We were focusing on observations and assessing impacts and mitigation strategies that SpaceX can use with Starlink and so forth. SATCOM 2 to be held tentatively sometime towards the end of Q1 next year will be much more policy oriented and trying to get some ground rules in place and try and produce some documents in ways that could be actionable by the UN, because as noted, this is a multinational problem, and it's going to require that level of setting ground rules to make anything stick.
Yeah, we're going to have to trust some entities that haven't been so trustworthy in the past. I'm a big fan of the blockchain database. We already have citizen scientists that track objects in very distant space and identify, and they're very good at that job. And this idea that we're going to track space debris that can potentially put at risk satellites or launches, any sort of vehicles, it's a job for them, for individuals who can really just do it as a hobby and really hone in on just what the potential would be for a collision, and then present it to the experts, and then the experts add it or don't add it to a database that is a blockchain-based database that can't be interfered with. I like the U of A is working on this right now. I don't know how far they've gone on it, but I don't know of too many other entities that are thinking about that. But at the end of the day, someone's going to have to handle that. Right now, it's the Space Force.
We are almost at the top of the hour, if you can imagine. It does go very quickly when we have such rich conversations. I'm thinking about our elementary school students and our middle school students, right? The kids who are going to be our leaders someday. Where do you see human space exploration in 50 years, 100 years? And is there a limit as to how far humankind can advance as far as space exploration goes?
No, I don't see any reason why we won't be like on Mars. I mean, we could always, probably, 50 years ago, people say we'd be living on the moon, but there's really no reason why we can't do it. And there's a lot of work that's actually being done towards that. So us living on whether on the moon or Mars there's really no reason why that can't happen in the next 50 years. And people are actively, obviously Elon Musk and SpaceX, but beyond that, people are actively working on that. And not just governments. I mean, that's. I just want to emphasize that statement I made earlier. The space is not the realm of governments anymore. Yeah. And so there are a lot of people that are working on this.
Yep. We were doing one of our live streams that we've started doing during the COVID shutdown last Thursday, and with one of the astronomers here at Lowell. And our topic for the morning was how spaceships have been depicted in cinema over the years, and who's done it in what way. And my colleague Gerard noted we talked some about 2001, which came out in 1968, and Stanley Kubrick and Arthur Clarke sketched out this vision where we had a 700-foot long manned spacecraft going to Jupiter or Saturn, depending on the book or the movie. And Gerard pointed out he has always contended that Kubrick got that exactly right if we had maintained the level of investment, as a percent of GDP that we were doing in the Apollo era. If we had continued to push forward and chosen to make that investment, there's no reason something of that scale wouldn't have happened. And so it's a matter of investment and where we choose to put our priorities. But yeah, it's eminently doable with today's technology. And it's astounding to think, given that, I was in grad school, when I first got this exotic $500 thing called a hard drive that was 20 megabytes, and wow, it's actually right there. And imagine what our kids are going to be working with 30 years from now. It's incredibly exciting to talk to them when we can be open and jazz them up about the amazing world they're going to live in the next decades.
I'll go a little further than that. My son graduated from Embry-Riddle Aeronautical University last December. He was also Air Force ROTC, so he just entered the Air Force. He's at Wright Pat Air Force Base. He's always had a vision of wanting to go to Mars, and now the Space Force is trying to recruit him from the Air Force. So he's applied. And he'll find out sometime in October whether or not he's going to be in the Space Force. So
that's amazing.
Who knows?
Good luck. Yeah, congratulations.
Yeah, that's actually the biggest problem. The biggest problem is going to be workforce, and workforce starts off with our education. And quite frankly, we are talking about STEM, and kids don't like math, and math is the core to STEM. But luckily, manufacturing is the foundation of STEM. And so we can get kids excited about building things that they want to build and then gradually apply the math. And I think it's got to start at 3 years old, which means we got to have parents involved, which means, yeah, we got some problems.
Well, but I will say this, my daughter who's 9 hates driving. She just hates being inside a car. And so she's constantly talking about inventing teleportation. I'll tell you, at 9 years old, I was not thinking about inventing teleportation machines.
But she'll be the one to do it.
Yeah, exactly.
Yeah.
But by the way, at NIST, it was maybe 10 years ago, they actually did move something. It was, I don't know if it was nanometers or millimeters, but they did move something in space.
Wow.
So who knows?
There you go.
Being a former educator, a third grade teacher, and in addition to an assistant principal, I really had to kind of cut my chops in the classroom around STEM. I'm a very language arts kind of learner myself, and I knew it was my responsibility. Same thing with my 3 kiddos. And it's putting those, you've each said it, it's putting those opportunities in front of them, especially when you're a parent like me who doesn't have a clue. I've got to take responsibility to get them in front of a variety of different experiences so that as they learn and grow, they can start being introduced to things that maybe in my limited little world, I wouldn't be able to do that. And we have, again, the SciTech Institute and the SEO program who does exactly that, giving them these rich opportunities to listen to, have conversations with, to take trips around the world, right? To have these incredible conversations and bring them to the school, right? And so our teachers are better informed and they too get excited about what we're doing in science and space.
And there's another element that no one likes to talk about, but quite frankly, space is very brutal for the human body. And so a lot of this is going to require individuals who are physically fit. Now, I don't know how much truth there is to that once you get outside of Earth's atmosphere. That's something that's being worked out as we speak. But the idea that Branson's going to be taking 6 at a time up into suborbit and orbit, those people are still going to have to be physically able to make that trip. And so there's this element of bringing us back to the caveman where we physically got to do things that doesn't require a lot of technology, just the willpower, the mental willpower to do.
And quite honestly, a lot of us have gotten a little cushy, especially during quarantine, right? Although, for me, I know I have to stay physical. I know I have to move. I had guests in here earlier who were talking about, the whole mind, body, spirit connection and physically staying in movement and how important, of course, nutrition and our food is and how our brain functions, all that. I think the generations coming after us, I'm seeing that they really are the leaders for us and they're taking more responsibility than certainly my generation did around some of these things, and I'm certainly learning from them. It is the end of our program. I am excited, Steve. I hope you are too. What a fantastic conversation today. Yes, thank you, each of us, for being here. Our pleasure. Before we scoot, if you could just go around quickly, reintroduce yourself, and let us know either a website or are you on LinkedIn? Where can we stay in touch and learn more about you and the business and organization you represent?
Sure. Once again, my name is Benjamin Hernandez. I'm a co-founder of the Arizona Spaceport Alliance, and the website is azspaceport.org.
And I'm Jeff Hall, the director of Lowell Observatory, and you can learn all about us at Lowell, spelled like that, .edu.
And so I'm with Worldview Enterprises. So worldview.space is our website, and I'm also on LinkedIn, so anyone can find me on LinkedIn.
Steve Zylstra, President and CEO of the Arizona Technology Council, aztechcouncil.org, and you can also find me on LinkedIn.
Excellent. Stay with me, gentlemen, after we go off air. So a quick for a quick photo or two, and then, of course, an opportunity to thank you personally for being here. Thank you for joining us today for Arizona Technology Council's podcast series, AZ TechCast. Thank you again. You've been listening to the broadcast from Phoenix Business RadioX inside Mac 6 Conscious Workspace. Today's AZ TechCast was brought to you by the Arizona Commerce Authority, the state's leading economic development organization with a streamlined mission to grow and strengthen Arizona's economy. Thank you, Arizona Commerce Authority. And many thanks as well to JDH Insights, the 2020 Tech Advocate sponsor. Visit jdhinsights.com to enhance leadership and improve team dynamics to take your business to the next level. If you are interested in being a podcast participant or a sponsor for the Council's AZ TechCast, please contact marketing@aztechcouncil.org to lock in your opportunity to further position you as a tech expert, influencer, and innovator. Thank you all again for being here. Have a fantastic weekend.